All right, good afternoon, everyone. Thank you so much for joining me for, I guess this is the last session before we have a closing keynote and then party and stuff like that. So thank you very much for coming in here. My name is Nash. I am a developer advocate at a company called Sonar. Sonar is the home of tools like SonarQube, SonarCloud, and SonarLint. They're all code quality tools to help you write cleaner code. SonarQube and SonarCloud live in your CI and CD pipeline and give you a quality gate as passing for new code. And SonarLint lives in your IDE to help you write better code right there as you're typing it. I'm not here to talk about that really today, but if you ever want to ask me questions about that, about anything I'm talking about today online, you can find me at Phil Nash, basically everywhere on the internet, Twitter, LinkedIn, Mastodon, insert new other social media network here. I don't know, trying them all. Just go to Phil Nash. It's my favorite URL in the world. It's just my name. It's wonderful. No, we're here to talk about passwords, or indeed the state of passwordless on the internet, on the web today. Passwords are terrible, right? I hope you kind of agree with that. That's a good starting place for getting rid of them, moving on to passwordless things. And there's many good reasons why passwords are terrible, but I do like to cover them just as a roundup before we get into getting rid of them. Google did a survey, this is actually a survey getting on a bit now, back in December 2018, asking people various questions about usage of passwords and other such things. And one of the questions was, how often do you reuse passwords? And so in that blue section is probably the most honest answer, right? It's about 52% of people said some of the time they reuse a password. And you're like, okay, that's fine. Hopefully your banking and your email passwords are the ones you look after. And then, good section, 35% of people said they never reuse passwords. I love those people, fantastic. I hope to count myself amongst them, and I hope to count all of you amongst them too. But I really like the bold nature of the people who said, all of the time. How often do you reuse passwords? All of the time. I have one password, a single password. It's all that matters. I assume it's tattooed to them or something. I'm pretty sure password managers and tattoos are not the same thing, but they've gone for it. All of the time, 13% of people reuse passwords. Stunning. We need to help those people. That same poll. Actually, I want you to remember this 35% of people who never reuse passwords, because the same poll asked if people use a password manager, and 24% of people say yes, they use a password manager. And it makes me wonder, like, the 11% difference there between people who use a password manager and people who never reuse passwords. There's like 11% of people who either have an incredibly good memory that they don't need a password manager, or maybe it's all just sticky notes around their monitor. Or maybe, I genuinely don't know. Maybe they're just lying, because you can do that to surveys. It's quite fun. Best not to, but nobody knows. So anyway, yeah, so 24% of people use a password manager. 3/4 of people are not using a password manager, according to this survey at least. And some weird number of people are never reusing passwords, but without this. And then, of course, it's always good to take a look into top passwords that people use. These continue to come out. Various companies like to do roundups of top 10 passwords. This particularly was from 2022 when NordPass did a top 200 most common passwords. And in at number 1 is password. That's my favorite, absolutely. I find like it's often a battle between password and 1, 2, 3, 4, 5, 6 as the top most popular passwords. And then I like the other ones, good lazy ones in there, including number 2, number 3, number 5, where you just have to type all things in a row. I like that. People should be a bit more creative, you'd have hoped, but no, we're never going to get over that. People choosing passwords choose them badly. It's a shame. It's awful. And then, of course, even if you were to pick a really good password, not from the top 10 or even top 200 there, there's all sorts of likelihoods that that password or passwords that you've used in certain applications have been leaked by those applications. haveibeenpwned.com is a wonderful place. If you don't know it, it's a great place to go and pop in your email address or phone number, and it will tell you whether your passwords for those accounts have been leaked somewhere on the internet. There's a horrifying amount of them, and passwords are terrible. For years, people have been leaking passwords out there. I got hacked myself because this happened. This was back when I was in the sometimes I reuse password section of the graph myself. And it's just a horrible time. So we need to get better than this. And as developers, as people building these applications, we need to do the most we can to protect our users and put them in a situation where passwords can at least work for them before we can then get to the situation where we can remove passwords entirely for them. And so that's kind of what I want to cover as we go on through this talk. You see, passwords and user authentication for any kind of application are basically a bit of a trade-off. A trade-off between user experience on one side and security on the other. Because hopefully we're trying to build applications that our users want to use as well. Like nobody ever comes to an application, to a website, or to anything in order to just log in. They come to achieve some of the task. They come to use your application, use your services. And so whilst we need security, whilst we don't want just anybody to be able to see anybody's data, we also want to be able to get people through that process as quickly and painlessly as possible as well. And so if we actually consider passwords on this trade-off between user experience and security, we find out that they're just generally terrible around. On the experience side of things, it's hard to remember good passwords. It's hard to choose good passwords. We've seen that in the top 10. And ideally, really, you need a password manager in order to remember them all. I think I have more than 400 different username and password combinations in my password manager. And the very idea I could remember a good portion of them, if they were all different, is just out there. But on the security side of things, they're also bad, right? This is what we've been through. It's easy to kind of break easy passwords. Like, it's very easy to go and take that top 10 or top 200 passwords and play it against a whole bunch of user accounts and hope you can get into one of them. And then, of course, there are those password leaks. So there's plenty of passwords, and with their pairing email address or phone number out there, the data that haveibeenpwned.com relies on, and you can just take those and apply them to other websites. Credential stuffing, effectively. It's wonderful. And you don't have to, as an attacker, you don't have to break everybody's account. You just have to break enough accounts that it's worthwhile. And then finally, of course, I haven't even mentioned phishing, but passwords are highly vulnerable to phishing. If only people writing phishing emails were better at designing them. I always think every time I come to a conference full of excellent developers, I'm like, this is a room full of people who could phish people like easily, so easily, writing a decent-looking email and a decent-looking login page and just stealing credentials all over the place. Like, don't though, but I reckon we could. Let's stay on the good side of things. So passwords, they're both vulnerable and a bad experience. We can do better than that. So first answer, of course, is use a password manager. That does make things a bit better, right? With a password manager, the experience somehow immediately becomes better. You don't have to think when you're picking your passwords, and you don't have to remember them when you're re-putting them into an account. You even probably have like a very easy autofill for that. And then you end up without repeating passwords and without worrying about things. And on the security side of things, you've now picked long, unique, difficult passwords. And whilst this is still vulnerable to phishing, it's less so, especially if you're using that autofill feature from your password manager, because it won't autofill on a different website that's trying to phish you. And this is great, aside from the fact that 24% of people use a password manager, leaving 3/4 of people not to use one. And we can't make people use other software in order to just use our application. So whilst I'm betting that most people in this room are indeed patting themselves on the back for using a password manager and never having to know their passwords, we're not necessarily trying to help ourselves here. We're trying to help all of our users. We're trying to help the users that are still using the password. So can we improve passwords first before we move on? Hopefully, yes, we actually can. There's a bunch of stuff that the browser can give us and a bunch of web APIs that we can get hold of that are going to make the process a little bit easier and just a little bit more secure. And first up, it's just in the HTML. I don't even need to reach to JavaScript for this. Using the autocomplete attribute of the input element is one of my favorite things. It makes the autocomplete attribute is one of the best things for both security as well as accessibility. It helps people fill in forms all over the place. And on an input with autocomplete of new password, a decent browser will suggest a securely generated password to people. So that's a nice start. This is what Firefox looks like if you do that. So suggesting a securely generated password is one step on the way. We can't make people accept that securely generated password, but it's a good idea that people should be doing more. Next up, if you are on a login page, for example, we can use autocomplete to fill in the username and then the current password. And that's a nice distinction as well there. We have new password and current password, which is particularly useful for marking up those pages where you're changing a password, updating a password. So autocomplete can fill in both the generated new one and the old one at the same time. And then there's the credential management API. This is an API that I don't think gets a lot of press. It's not very popular, but I think it's something we should consider. Because the credential management API is built into browsers to effectively have them act as the user's password manager without the user having to do much about it. The credential management API allows you to store and retrieve credentials in that browser. It's a fairly straightforward API. Like, there's not too many lines of JavaScript to it. And so if you're looking at this point, you need to check that it exists, although I think it is available, or password credentials are available in most browsers. If the password credential is available in the window, you can create yourself a password credential using a user ID and a password. This is something you want to create once you know that password works. You don't want to be storing old or incorrect passwords. But once you know that a user ID and a password works, this is a registration or after a successful login, you can ask then for the navigator credentials store. Just ask the browser to store the credentials. And what this is actually going to do is pop up the browser's permissions dialog to say, hey, do you want me to store your username and password? This is actually stuff that users see anyway. But the brilliant part of using the password credentials, the credential management API like this, is that once you ask that, you are then able to retrieve those credentials from the browser as well. And so if we move on from there, we can then retrieve them. Any credentials that we help store, we can retrieve. And so when you then bring a user through a login page, you can ask navigator credentials get, asking for the password is true object, and that will pop a permissions dialog to the user to say, hey, do you want to log in with these details? And once you get that back, you get the credential object back, you get that user ID and the password, and you can use it to autofill a login yourself. It's also possible to do that silently. So you can actually do it without a user interaction. And whether you do that or not is up to your own risk, I guess. It is important to note that if you want to avoid automatically signing somebody in when they actually log out, you do need to call on navigator credentials prevent silent access to avoid that. And what this looks like is, this is screenshots, yes. What this looks like is, this is on an Android device. When you go and log in, it's going to pop that regular browser Chrome to say, do you want to save this password? And when you do, the next time you come to log in, this is the permissions dialog to go and retrieve the passwords. It gives you that user ID and say, do you want to sign in as this person? The user hits sign in, and they can go straight through. Wonderful. That's the sort of thing you can trust on somebody's device. It's the sort of thing you shouldn't do on shared computers, but we've been teaching users that for quite a long time already. So the credential management API and the password credentials like this actually give us the ability to give users like one-click auto-completed logins without the use of a third-party password manager. And they don't need to remember their passwords either. It's built into the browser's password manager, which honestly, for most users, is good enough. And so that's cool. And then on the security side of things, we still have to encourage people to use those generated passwords, and we can't guarantee that they're going to. So they might still use easy to break passwords or passwords they've used before. And again, like, this is one tiny step on the way away from phishing, because if a user expects to be asked if they want to just log in, that's how they normally log into your application, and they're not getting that pop-up because they're on a phishing site, they might think twice. It's slightly less vulnerable. It's nice. We're going to come back to the credential management API because it turns out it has a lot more to offer us. But for now, I need to go back on the security side of things. We improved the experience there, but we didn't really improve the security side of things too much. And that's where two-factor authentication comes in. Two-factor authentication, of course, is that text message you might receive or the application generating a code on your phone in order to allow you to log in. It is the proof that you have a device or a phone number or something like that that you've proved before. The idea that you have something as well as you know something, the password. It's a bad experience. It turns out if we try and improve the security on things, we take a step back in terms of experience, because now we have this two-step process to go through. We need another device. We need to perhaps have phone signal if you're using text messages for this. So it's not particularly useful if you're in a plane or underground. It needs you to go and get that device and do something about it. One of the worst parts, I think, of two-factor authentication for me is how I'll go to log into a website, pick up my device, and go do something else on my phone instead. And then 20 minutes later, it's just like, are you gonna log in? And then the code has expired, and yeah, it's a bad experience. I mean, I had a great 20 minutes just scrolling something, but like, it's not great for what I was intending to do. On the other side, the security is better, right? Now we're no longer relying on a user to choose a good password, or even if that password is leaked, the second factor can help to protect that. It is still vulnerable to phishing, of course. If you can build a phishing campaign that will take in somebody's username and password, you can build a second page that can ask for a code as well, and then replay that attack straight onto the original site. And it's not entirely infallible in terms of attacking people's second factors. You can steal physical devices. You can target SMS attacks. You can target people if you know their phone number with a not necessarily trivial attack to pull off, but you can intercept text messages if you want to. There's a surprising lack of security in the SMS world, and you can ask me about that later if you're interested in more of that. But for most users, and again, I'm thinking of most users here, two-factor authentication via a text message is a wonderful thing and keeps them a lot more secure. This was actually an argument against when Twitter, X, decided to turn off two-factor authentication via SMS for users that weren't paying. A lot of people in security celebrated this because they were like, SMS is not that secure. But it turns out it's more secure than no two-factor authentication, and so removing it for people is a bad idea. And then on the other hand, you could pay to keep the less secure version as well if you wanted to. Like, people paying for subscription were allowed to continue to get text message two-factor authentication codes, and arguably people who were verified were more at risk of these things. So that was a bad call. But can we make two-factor authentication better? Can we make that experience of grabbing your second device a better one? It turns out yes. First up, the autocomplete attribute gets back involved again on our inputs. And this is a feature in Safari, iOS and desktop. If you use the autocomplete one-time password attribute, then yeah, Safari will help autocomplete your codes. And so it looks like this. If you're going to log into a place, we put our username and password in. It logs in. It's sending the text message in the background. And when it arrives, it's right there. You can just use that. I always do this too quickly. It's right there at the top of the keyboard in the autocomplete place. You don't have to open another app in order to get involved. And then the best part about this is actually it does work going to make that full screen. It does work on the desktop as well. If you are fully bought into the Apple ecosystem and you're using Safari on the desktop and you have iMessages set up to route through your desktop as well, then yeah, stop that. Quite magically, even though you're not receiving a text message on your laptop, it will appear as an autocomplete and allow you to fill it in. And I think this is brilliant for like an extra, what do we say? An extra 30 characters. You just get all of that for free. It's kind of nice. And then Android and Google went a different way, of course, with what they call the WebOTP API, which turns out is actually just the credential management API again, just with a different object to use. So it turns out the credential management API is actually what this talk is about. I've suckered you in with passwordless, but we'll get there. But it is the credential management API, I promise. To use the credential management API to help text message-based two-factor authentication get better, you do need to alter the text message slightly. You need to add, on the bottom line of the message, an @ symbol, the domain that you're logging in on, a hash, and then the code. And that allows for the operating system to both make sure it's only auto-completing things on the correct domain, and then, I guess, makes it easier to pass the number out as well. When you've added that, we look for the OTP credential in the window and ask navigator credentials get to get the OTP with the transport, and the transport is an array of a single string SMS, which is an odd API, but I'll come back to that in a second. If you ask for that, it will pop a permissions dialog in the browser to say, hey, we'd like to read your text messages and get this number out. Is that OK? And so if the user presses yes, you get a little object back with a code property, and you can use that to fill in the form and submit it automatically. It looks a little bit like this. Let's show this one. This is on an Android device now. We go and log in. Ready to pause, because I know I go through this too quickly. So weirdly enough, both the text message comes in at the top and the permissions thing comes in at the bottom. But they're both showing basically the same thing. And yeah, if you press allow on that permissions thing at the bottom, we can fill the form in and just move on. That's a nice one-click experience there as well. And so right, we're improving the experience again. We now have two minimal steps. If we're using the credential management API for both the passwords and WebOTP, under the right circumstances, it's basically 2 clicks of a yes. Oh, notably, you can, it is possible to, in Chrome, if you are into the Android ecosystem and everything, or you're always using Chrome, you can do that across to desktop as well. It will autofill from the desktop from your mobile device. I'm an iOS user, so I found it very hard to capture that and get it right. I have seen it happen. It's cool. And again, you don't need to do anything different in the code to have it work on desktop. It just needs to be happy to work. It does still need your other device. It does still need phone signal if you're using text messages. But the experience is improved, so that's nice. And then the security is good. We already talked about the security of two-factor authentication. We're better with that. I will point out, this hasn't necessarily helped with authenticator application-based two-factor authentication. But I think that's what that array with just the single parameter of SMS is for. It's an extensibility thing. The web is always building to be open to extensibility, and I always appreciate that when people design APIs like this. Hopefully with enough work between browsers and operating systems and mobile device manufacturers, they can, and authenticator app manufacturers, right word, they are able to perhaps have authenticator app as an option for that array, and we can just do one-click inputs for everything. And then there's two-factor authentication with a security key. This is probably something that you are perhaps using if you have a YubiKey or similar to authenticate with various things. And this uses, on the web, uses the browser's web authentication, WebAuthn, which of course is just the credential management API, but a different type of credential. And in this case, the code to deal with this, So what happens is your server needs to send a challenge, a bunch of random bytes, down to the browser. And when it does so, we fill in this credentials creation thing here, where the challenge from the server comes in here. We have an RP, that's the relaying party. It's the domain you're working on, you're trying to log into. Some details about the user, and then these are just sort of algorithms for encryption for that. And then once you've done that, it will pop a permissions dialog. You need to interact with your YubiKey somehow, or whatever the key is somehow. And the challenge is returned, encrypted, with the public key. Private key is stored on the device and sent back to the server. The public key is sent back to the server with the challenge, at which point the server can use the public key. Oh, sorry, the challenge is encrypted with the private key sent back with the public key. The public key can be used to decrypt the challenge and see that it was the original set of random bytes. Now know that that user account is connected to that device. Then back on the other side of things, we then use credentials get, using another challenge from the server, but this time we're not trying to create it. It does know that it's only on that domain, and therefore we can just ask it to sign the challenge. We get the encrypted challenge back. It can be decrypted by the public key on the server, and again, log the person in. 1 second. The screen went off at the front. I don't know if that's something we can bring back. Thank you. So two-factor authentication with web authentication is great. We now have 2 minimal steps, like it's just a touch to your device. But the only sad thing about it is that you need to have those authenticator or platform authenticator keys to do it with. We probably have a key like that because your business has given you one to keep things secure. But for a regular user, buying a security key is probably not something they're thinking of. And secondly, you then also either need to register multiple devices or move that key around to different devices to use it in other places. But the security is great. It is a second factor, but it's also public and private key cryptography. The only thing that gets shared and never leaves the device is the public key. A public key is fine. It's public. It doesn't matter. And it's phishing resistant as well. You can't, the browser will refuse to use this on anything but the original domain on which it was registered. And so you cannot leak these, and you cannot accidentally use them somewhere else. Brilliant. So let's get rid of passwords. That's what we kind of wanted to do in the first place. But I do think it's important to both see the progression as to where we've got to from here, and also work on improving that as we continue to build things for our users. And as we continue to kind of try and move them over to these new and better things. And so the passwordless stuff, well, I'm going to take a little diversion. Magic links, I think, are, technically passwordless. The idea that you can get sent a link that will allow you to then log in via clicking that link. And it's, look, there's no need for a password, which I like. But there's nothing I like less than going to my email just to log into an account. That's a bad thing, and so it's just friction. We're actually adding a step back in terms of experience. It's pretty secure, I guess. I just don't like them that much. Let's not push this too far. We've got better things. I actually have one application I have to log into for work, which requires me to put a username and password in, and then they send me a link. So that's just passwords and passwordless at the same time, which is very annoying. I'll be sending them feedback. So moving on, passlinks. Passkeys are wonderful. They are multi-device credentials. They actually build upon everything that we've seen already in order to provide a much better, more secure version of all of this. It is, of course, it's based on web authentication. So again, it's just the credential management API doing its job quietly underneath a bunch of other names for it. And what it's good at is it verifies the user on the device. So it uses the platform authenticator. It uses your fingerprint or your Face ID or whatever your kind of platform makes available as a sort of biometric thing. But that biometrics never leaves the device. It's not something that you're going to accidentally share. It's real hard to revoke fingerprints and a face. whereas revoking a password is a lot easier. So it verifies the user on the device, proving that you were the same person who set a passkey up in the first place without ever having to leave the device. And then once it's created that public key or that signed challenge and sent that back to the server, that's the authentication side of things. And so it's almost a two-factor authentication in one factor, which doesn't seem right, but it kind of is. And then the beauty of passkeys, that aside from being able to use, we're using the platform authenticator, which is great. It's built into the devices people have. But unlike using web authentication and a plug-in USB key or something like that, passkeys can sync across your devices based on your platform account. And then, because not all platform accounts can talk to each other, if you use iOS and Windows, or if you're using Android and a Mac, those platform accounts don't talk to each other. There is then a cross-device syncing mechanism, a cross-device mechanism where syncing doesn't work. So it's best to show this. I'll chuck some code in first. I have to show this code because I think it's wonderfully Java, even though this promise is still JavaScript. There's a couple of things to check to see if web authentication is available and then passkeys are available. You have to check for, is the user verifying platform authenticator available? That is, do we have a device to take a fingerprint or a Face ID or whatever? And then, is conditional mediation available? That allows you to show a login dialog. If you have both of those, then we basically go back and do the web authentication thing again. It still looks a bit like this. We're creating a public key in this case. But the important parts are the authenticator selection. We want to have authenticator attachment as platform. That is, we're asking for the platform authenticator itself. And then we ask to require a resident key. That stores the key in the platform authenticator, allowing it to then sync across your platform devices. This is what it looks like. This is just using a passkey demo on passkeys.io. And so I'm signing in here in Safari and desktop and creating a new account and then saving a passkey. And so Safari then asks me, hey, use your fingerprint on your laptop to authenticate for this, and we'll secure that passkey. So it's created an account. We're now going to sign out. We'll go sign in again just to see the sign in process. That also gives it time to sync to the device that's to the mobile device. Now, I've done this demo a few times before I recorded it. And so we're looking for the demo with my Sonar source email address in when we log in. So we've managed to log in on the desktop. Now let's do it on the iPhone next to it. We're going to do it with a passkey. And like I said, we're using the Sonar source one. That's the one at the bottom there. It's using Face ID in this case to log in. And it's happy. It's logged in. And so now we know that we have that passkey available on both of those things. And we can go to a different browser, in this case, Chrome. Now, Chrome does not sync to an Apple account yet, but what it does do is allow you to pop up this QR code. We can then use the mobile device to scan the QR code, which everyone's good at these days, and it will ask you to sign in with a passkey. Now we do the authentication on the mobile device, and it sends that data over to the browser and allows you to sign in there. At this point, you would then offer a person to authenticate, to register a new key so that they don't have to do that process again. But it's a wonderful little thing there. Well, a wonderful experience, really. After logging in, signing in for the first time, all I ever had to do to sign in was to use a platform authenticator and get past that. It's actually possible. I still don't think Chrome does it yet, but it is capable of looking into, for example, Apple's where you store passwords and keys in Apple. Sorry, I can't remember that right now. Yes, Keychain, that's it. It can look into Keychain and use that as well. I don't use Chrome that often, so I'm not entirely sure if it's doing that yet, but it's possible. It's also possible to build third-party plugins to do this as well. I'll talk about that in just a second. It's kind of useful for even better syncing. Right now, passkeys is, if we look at the experience side of things, we don't need a password ever anymore. We just need to have a device that we are authenticated with and able to authenticate. It's kind of, the issue with it is that you do need one of these devices with a platform authenticator on them. And again, maybe not everybody has those, so we can't necessarily drop everything else we've done just yet. But we can upgrade to this system to give people who do have it available the best possible chance. And it does. That syncing is wonderful. It's almost seamless. It's particularly seamless if you are indeed in the same network of devices. On the security side of things, it is public-private key cryptography. It's phishing resistant. It's unleakable. And as not an actual security professional, I'm almost able to say, is it perfect? Nothing's perfect, but it's definitely better. It's the best thing I think we've seen from everything I've managed to present today. And I definitely think it's something we need to think about. There are a couple of the drawbacks, of course. Browser support. I'm a Firefox user still, and they still haven't managed to implement passkeys yet. But it is in all the other browsers, so, you know, almost there. It is coming. It's been coming in 2023 for quite a while, and we're running out of 2023. But I trust Mozilla. They can get there. As I said, there are plugins available to do this as well, and 1Password has actually gone all in on passwordless stuff, which is really cool. With the 1Password plugin, it can take over that process of using the credential management API and do the storing of the credentials itself. And then because that 1Password plugin is available across platforms and across browsers, including Firefox, it actually it can do that syncing for you, which is very cool if you are a 1Password user. They're also maintaining this passkeys.directory, which is a list of places that you can now log in using a passkey. And the list actually keeps getting longer by the day. I think it's only in the last couple of weeks that Google themselves have actually opened up the ability to now use a passkey as your primary kind of, I wanted to say password there, doesn't make any sense. Use a passkey as your primary method of authenticating for your Google account, which is great. GitHub did earlier in the year. Microsoft have done so. eBay, Amazon, they're all kind of getting on board, and it's time. It's time to do so. And so that's why I just want to finish with a couple of recommendations for this, because I think it is the time now to detect passkey support and offer it as the kind of the default way to authenticate to your service, and bring it into existing user accounts. It's in the right place. It's right to go. Support multiple passkeys. That's still important for those people that can't necessarily, or using devices that won't sync between them. You do need to support multiple passkeys. Then, in order to keep people secure, you do need a fallback to passwords and two-factor authentication for those that don't have a platform authenticator, for those that don't have a device that will work for this. And then, if a user can use passkeys, you can upgrade and even remove those old, weak credentials. The passkeys are tied to their platform accounts, and as long as they can get back into, in this case, my Apple account, or a Google account, or a 1Password account, if that's what you choose to use, then you can't lose these passkeys. They are stored and encrypted and stored in the cloud as well. And so I have some links. I'll share the slides out in a bit, yeah, a whole bunch of stuff there. Other than that, I'm excited about getting rid of passwords. I can bring those back, sorry, if you want to take pictures. I'm excited about getting rid of passwords. I hope you are too. Again, my name's Nash. I'm a developer advocate at Sonar. And thank you again for joining this afternoon. Thank you. Yeah, I've been turned off. I'm assuming because the lights came on, we don't have any time for questions or anything, but I will be around for the rest of the conference, so come and find me. I'll normally be in purple or something. So thank you. Thank you.